Thank you very much, and welcome to the Derwent Rooms for the second talk of this bracket. For this talk we have Mark Rees, who is a programmer of more than 25 years experience and has been coding in Python since 1997. During that time he's been a contributor to many Python open source projects. He's a regular at PyCon Australia. He's presented at both of our Sydney conferences. He's also past convener of the Sydney Python user group. Today Mark will be investigating whether PyPy is ready for production. Please make him welcome.
Thank you. Okay, firstly, these slides have been passed the PyPy team. So they asked me to say I'm not affiliated with the PyPy team. And the opinions expressed here are not their opinions. Me and PyPy. So I'll start. There was a Python programmer, a Java programmer, and a Perl programmer, and a guy with a Gaelic accent in a pub. 2004. Second night of OSDC, and we were talking about projects that we did, and he said, I'm working on this project where we're going to write a Python interpreter in Python and it's going to be faster. And we said, and I can't repeat it because it would be a code violation, and that was my first experience with PyPy. I'm a little bit of a alternative Python implementation junkie. I've spoken about IronPython. I've worked on the community version of IronPython. We use Jython at work a lot. With all our products, CPython is shipped, but we also ship Jython for various reasons because there's some libraries we need to use. And so I have been keeping an eye on the PyPy project. And sort of randomly, when they do a release, I might download it or I might not download it. And when 1.8 came out, I downloaded it, ran it. It felt faster than it had felt before. And I thought, is this the time to work out if PyPy is an option for me to improve some things where we're having a little bit of a performance issue with our CPython code? And I'll talk in more detail about that. So that was the question. This is what this talk is based on. Sadly, I'm a manager now. I still want to be a programmer. So this is my little project. And being the boss, I'm allowed to go, you're not going to do this one, I'm going to do this one. Okay, so how many people know what PyPy is? Good. So it's not the package index, it's the Python interpreter. Okay, no, there is a bit of a problem because PyPy is actually two things. And people tend to get it mixed up. So the first one is, it's a framework for building dynamic virtual machines for interpreters. And that's done in a subset of Python called RPython. And PyPy is the ultimate example of what you can build with RPython. And if you want to hunt around on the web, you'll find various attempts at taking languages like JavaScript and subsets of Lisp or Scheme. There's even a PHP interpreter, which was done as a proof of concept. But some of the nice features that the translation framework gives you are not specific to Python. So you can use it for other things. But this talk is about the Python version. So as I said, my first introduction was 2004, but it's been around since 2003. It was a EU project, so it got a lot of funding. And so on the web you will find academic papers about it. It's a very refactored project. There have been some, we're getting there, didn't quite make it, let's rethink about it. I would suggest this is the third or fourth iteration, don't quote me on that. But the big thing was the adding of a just-in-time compiler, which all of a sudden took the benchmarks up. So they used to go to PyCon each year and they go, we are 16 times slower than CPython. We are 8 times slower than CPython. We are 2 times slower than CPython 2. We are now faster than CPython. They considered the first production-ready release was 1.4. I never downloaded that one. Okay, the other thing, since this talk is about the benchmarks and stuff, so on the slides, which there's a link at the end of where it'll be put up, these are things that I found really useful. The documentation on the PyPy site has got a lot better. There's a link to a blog, which is really worthwhile reading. And these other 3 links are actually YouTube videos, all talks from PyCon in the States this year. Really good, solid introductions if you want to understand the underlying how PyPy works, or you want to see some cool things that are running. Okay, so production ready, it's sort of a very vague term depending on who you are. You can take the business definition, which is it runs and will it make money? But this is more the programmer's definition. So this is how I'm going to measure whether what I believe is production ready. And I threw a few other things in as well. So what's important to me is, do I have to rework my code? And is it as fast as CPython, or hopefully faster? Because as I said, my original question was, am I going to get a performance improvement out of running PyPy? So we'll sort of go through the list. Does it run? Yes, it runs. So it's exactly like Python when you start it up. The good thing is you can just download the binary. The big thing to remember is the stable version runs only on x86, 32-bit or 64-bit implementation. All right? There are other back-end implementations for ARM, PowerPC, Java and .NET VMs, but they're all in different states, and some of them need a lot of love. But looking at the check-ins of late, the ARM and the PowerPC, one seems to be getting a fair bit of work. You will also see backends for JavaScript and stuff, which also have gone away and died. This is a little bit of a problem for me because we have to support things on other platforms other than x86, but it's not the end of the world. PyPy implements Python 2.7.2 with some 0.3 adjustments. Okay, the others. Does it satisfy the project requirements? For PyPy, I guess it did. I mean, I can't really comment on that. They got money from their grant, so they must have satisfied their project requirement. My project requirement comes more about when we talk about benchmarking. I'm not a language interpreter designer, so I can only assume the design was well thought out. I would suggest with all the refactoring, it is well thought out now. Is it stable? All the playing I've done with it and using it in the benchmarks and some production runs and things, I haven't had any Python equivalents of blue screens of death. There doesn't seem to be memory leaks or anything like that. Is it maintainable? And I gave this a 7 out of 10, and the reason why I gave it a 7 out of 10 is exactly the same reason, in my eyes, why I'd probably give CPython a 7 out of 10. I'm looking at it as a Python programmer, how maintainable is it for me? So PyPy is written in RPython. A lot of it is RPython. It is a subset. How you use it isn't very well documented. It's getting better. David Beasley said in his talk, if you love Python, you will hate RPython. So the architecture is quite complex. So if I had to, for a reason, because the reason we use our open source software in the company is, worst comes to worst, we can maintain it. That is a little bit of a concern for me. Mind you, the PyPy guys do now consult, so that is a fallback option for me. Is it scalable? It's as scalable as Python is scalable, so depending what side of the fence you're on, you can say it is or it isn't, but it does actually have stackless built in. So you've got options for massive concurrency that way. Is it documented? One part's very easy. It implements exactly the language of 2.7, so all the CPython docs are exactly the functionality of how it runs. Where it's less, as I said, is the RPython, and the toolchain is documented, but not as well as CPython is. So, you know, it's depending on how much you want to dive over the fence and look in behind the scenes, you know, maybe you give it a little bit higher. Does it work with the models we use? I know it's a very crowded slide, but I should have really done one of what's missing, but for us, and we'll get into the only thing that we had a problem with, we try to stick with the standard. If we go to using external libraries, they tend to be the ones that are more commonly used. So the big difference with PyPy is the CPython modules that have C extensions to power them, they tend to be written in pure Python in PyPy. Okay, they live in a directory called lib_pypy, so they still sort of work in the concept of there's this extension module, but it's in pure Python and relies on the speedups that PyPy give you. The other thing is a lot of third-party libraries work, so C-types work. So because of that, things like Piglet will work fine. And then SQL Alchemy, I've repeated it twice, don't know why. Python imaging library works perfectly. There's a nice compatibility list that you can go to. Just be careful. A lot of the things that are listed there actually have a red mark beside them, which means they don't work. So first of all, you go, yes, no. Okay, so this slide here sort of shows how PyPy can be hard. All right, so we use Report Lab a lot. And when we installed it, because in PyPy you just install as you naturally would, pip install, installs, compiler fires off, because PyPy has a C API compatibility layer. And Report Lab has some speedups, accelerators written in C. They compiled, and I went to run one of our scripts, and I got this error. And it's really hard to work out where the problem is. But that was the only compatibility issue we got with every single piece of Python code we run in-house. All right, and it was not a major problem because Report Lab does have the fallback of exactly what these accelerators are for. They've got Python equivalents just in case you didn't have the C compiler or the libraries. So it did work. Your mileage will vary depending on what C extensions and stuff you use. Okay? You can only but try. Does it run as fast as CPython? Well, according to their benchmarks, it runs much faster. And so there is a website where you can go to, speed.pypy.org, and every night they run against the nightly build, a full set of benchmarks, and they push it up onto the site. And there's some other good graphs that compare what their performance has been like over time and how they improve. So they, it looks pretty good. But, okay, and this is where I have a slight disagreement with the PyPy team. Their benchmarks, and I would say it's one way of doing it, are a very small, targeted piece of functionality. Okay, so if we take as an example the Django benchmark, which is the third one from the left. Okay, massive performance improvement. So basically, that is just testing Django template rendering. Okay, so when you see things like that, you just need to be careful because people might believe, oh, Django is going to be that much faster. Now, if your Django site is heavily into templates, you are going to see a really good performance improvement. And I think that's one of the sort of cool things about what the PyPy guys have done and what they've achieved is you can run the whole Django stack on PyPy. But, as I said, is the benchmark, whichever I keep getting pointed to, is the Django benchmark. Now, this was the original benchmark from Unlaid and Swallow. And as I said, it's fine. When you're trying to work out how things are working, you have small standard ones. But when you're in enterprise, you know that you don't get all the wins from those little things. It's the old 80-20 rule, and sadly, 80% of my code isn't going to be Django template rendering. It'll be something else. So what I tried to do was create workloads which are closer to what we use at work. And so not very complex, but a little bit more mixed, where I/O is involved. Okay, so I'm running the CPython and the PyPy on the same platform. And we do a lot of extract, transform, load stuff with Python. Okay, so minimally 100 megabyte files come in, but they can get half a gig. So they run for quite a long time. So my benchmarks are a little bit more of a mix. And so what I wanted to do from a benchmarking point of view is I wanted to use the same benchmarking suite that the PyPy team uses. So I did, they have it sitting up in Bitbucket, so I downloaded it and, cloned it. And so it's sitting on Bitbucket and there's a link so you can all see it. Added my benchmarks in. And so in the same environment, I ran their benchmarks just to make sure I was getting the same level of performance improvement, which I am. It's only a little VM, so I also ran it on some physical hardware just to make sure, again, so I got similar results. So the first one, which is basically this one that you're seeing here, so this is a 100 megabyte CSV file, which is US census data. It gets parsed, a little bit of work done on it, and then we output some XML. And so, excitement time. It's faster. Excellent. The only issue was I'm thinking, but I thought it would be faster. So I thought, well, I'll pull it apart. And so I did the CSV first. And it's slower. So all my gain was actually in my XML generation. And I'm like, this is looking really bad for the rest of my benchmarks. I'll go in a little bit later on, I'll go into what actually the reason for this was. So I kept on going because I had to get my slides done. So this is a pure Python Excel manipulation package. We use it, pulling in quite a large Excel spreadsheet because we get a lot of our data in that. And again, a little bit slower. Something we do a lot of, as I said, we use ReportLab a lot. We've got a really big project up in Malaysia where we generate lots of reports out of a website which is not in Python, and it all has to be in PDF, and so we actually use XHTML to PDF with some modifications. Again, not too bad, but again, not what I was expecting. And then I thought, just for completeness, because they tell me the memory usage is less, I will run the memory thing. So hidden in the bowels of the benchmark suite is you can actually track memory, so I re-enabled all that. And so the first one is basically just the interpreter, because one of the things the PyPy guys said to me, they accept that the interpreter does use a lot more memory than what the CPython interpreter does. So that's basically to give you a baseline. And also, just in case, with both sets of benchmarks, I was using the nightly build. So the last time these benchmarks were run was Thursday night this week. And so again, if you have a look at them, the memory footprint's bigger in all cases for the PyPy. For me, that's not an issue, but for some people, it might be. It's something that they're working on. But as I said, the CSV thing was something that really interested me. So what I did discover is where the slowness was when it makes the call to the extension, which in CPython is in C, and in PyPy is in pure Python. So that meant I could go look at it. They have some nice little tools. So they have a JIT viewer, so you can basically see where it's optimizing the code or not optimizing the code. And you can get right down to, so those are the instructions that are happening in the interpreter, and then you can actually even get down to assembler. And so you can sort of see things. It's really interesting. You discover how many times you're looping. And with a bit of a hunting and also a hint from an issue that was in the PyPy tracker, I started poking around in the _CSV Python module and managed to get this. So I really don't think 0.8 slower is, I would say it's on a par. There's almost the jitter of my benchmark there. So that's, I thought that was cool. I mean, if I was CPython, I would have been stuffed if I was in there looking at underscore CSV.c. But I was able to sit there, play around with it, because it's a Python module, not an RPython. All it was a case I could make my change, I could rerun my benchmark, I could relook at the JIT viewer. I didn't have to rebuild PyPy. A lot of people seem to believe that you have to constantly keep rebuilding PyPy. You don't. And so I actually got a good improvement for that particular one, and I intend, when I get some free time, to look at those other ones and see where else I can get things from. So we need to go back through the list. So if we take items 1 to 7, yes, PyPy is ready for production. Exactly the same as Jython is or IronPython is. Okay? It meets all the criteria, and if I compared PyPy to Jython and IronPython, where I've probably marked down PyPy in some places, I would probably mark down those other alternative implementations. So in that respect, it's pretty good. You can say it's production ready. I think number 8's one of the most important ones, and as I said, we were lucky. We only had one module where we had a problem, and the saviour for that was relatively easy. But your mileage will vary. Number 9 is the one where it gets a little bit more interesting. If you're looking at PyPy just for performance, it's all going to be about benchmarking and deciding whether that's the criteria for production. All right, I'm being unfair in some respects to PyPy, but for me, to put the effort in to test all this and to deploy it at client sites, there has to be some reason for doing something that CPython is already doing okay. You know, do we focus on modifying our Python code to work better under CPython, or are we going to get a big win by taking some risks by putting Python out into production? I had hoped that my big win was going to be in the PDF generation, because that's where I've got a problem at the moment. So at the moment I'd say, no, I'm not going to be deploying for that. I mean, hopefully sometime over the next 6 months we may find an issue, or some change in PyPy may mean all of a sudden I get the leap that I want. But looking at the benchmark results I got for the CSV to XML conversion, I think it's likely sometime in the next 6 months we will probably deploy some ETL workloads using PyPy. There's a couple of projects we're working on which I have some concerns in my stomach that we may have to actually look at that. So that's not the finish of my talk, because there's other things that you need to consider. It was just about production. So last week, they released, I don't know if everybody said it, the C foreign function interface. All right, so it's something they've been developing so that they get better performance when they call C libraries from within PyPy. But it works with CPython as well. And it's really cool. You can copy a manual page of a C function and basically into it make a call, and then it compiles it in the background, and then you can talk to the C library directly. So for some of the things where they've been having some problems with, like LXML and things like that, that is an option for them doing a non-C API type interface for bringing some C code in. They're working on a NumPy compatible module that's totally written in RPython, and they're getting really close with that. And the Python 3 version, there's a branch, and that's getting really close to passing all the tests as well. So, as I said, I didn't want to do PyPy an injustice because I was totally focused on performance. It's a really, really cool project, and there's little things that come out of it that actually help the community overall. So the other thing we'll do a plug for them for, they do have a donation page. So they survive by grants, so the Python Software Foundation has given some grants for them to do work, but they have specific donation pages for the NumPy work. There's Armin, who is working on a software transaction management thing to try and improve concurrency and things like that. Again, if he can get it working, because he wants it to be something that could possibly roll into CPython, it's really good for the community. As I said, the slides are up. It's a slightly earlier version of these. I will update them with the later ones. And if anybody wants to talk to me, I'm here until mid-Tuesday afternoon. I was asked if there was going to be a PyPy sprint. I might be working on trying to make some of my stuff go faster in PyPy if you're interested. But if anybody's got questions, I'm happy to answer them.
How does it go with the global interpreter lock and all that sort of stuff?
Exactly the same as CPython.
That's what the software transactional memory stuff
Yeah.
we're working on is
Yeah.
meant to address. Any more questions? Yep.
There's a bit of a naive question because I'm totally out of the loop with PyPy. You said Django runs on PyPy. Are there any... I'm very lazy. Do I need to do anything, modify Django, do any...
Nope.
Just runs?
Just runs.
Brilliant.
Where you'd have to watch out for is like if you use Report Lab, as if you had the Django plugin for that, then you're going to get exactly the same problem I did. Go and delete the .sos and you'll be fine. Yeah.
Thanks, Mark. I was just looking at your benchmarks before, and one thing that struck me a little bit was that all of the short-running benchmarks, they were the ones that were all slower, and the long-running one was the one that had sped up 3 times. And I was wondering, is it perhaps like a startup initialization cost? What, like when you just to run PyPy?
Yep. I mean, yeah, I did look at that as an issue. The interesting thing is, I failed to mention I'm doing 50 iterations of all of those. So you're just seeing the speed of one iteration. It does improve if the way the JIT works is around about 2,000 loops. It starts to trace, and there's a fudge factor involved so that not everything gets compiled at once. And depending on how functions get called and things, it'll still keep trying to optimize through. The other thing which is quite neat is the regular expression engine is actually jittered. So if you've got regular expressions, you get some interesting things. I didn't get a chance to get that benchmark good enough, but that was really good demo. But yeah, no, I looked at that. It's just the XML one was long because of a lot of data. And as you would have seen on the JIT viewer, we were 400,000 loops in just that one benchmark. But in the XL one, which was reasonably short, the JIT viewer, I think there was about 16,000 loops. So the JIT should have kicked in.
You mentioned that you don't need to rebuild PyPy after modifying the Python files that go in it. Could you expand a bit more on that?
Yep. Okay. So I mean, PyPy is written in 2 types of Python. So there's the R Python, all right? So that's the stuff that you do have to regenerate for. So if you're down into the core of the interpreter, where the R Python is, if you made a change there, yes, you have to regenerate it. They do have some things where what they have is they have a very slow mechanism where you actually run it with the normal Python interpreter and you can run unit tests, and that's their suggestion for if you're making little tweaks in the back end part of it. But in a lot of cases, because where I was looking at it from a production point of view, it's where the C extensions would be for CPython. That's in pure Python, and because they're loaded each time that you run it, of course the optimizer hits that. So that's for the type of thing I was doing, that's where I didn't have to rebuild it. But they've, one thing that has probably never been put across well enough until when I saw those videos from PyCon this year, is they sort of went up and said, you don't need to rebuild it for every single thing. A lot of it is all about just making sure, did I get a small improvement? And you run it through a little thing called py.py with the C interpreter. Runs 2,000 times slower, but allows you to test out your changes. So that, because they say 45 minutes to build, best I can do is about an hour and a half, and I've got an i7. So I want to know what hardware they've got. But no, it's an interesting project, and maybe my talk next year might be about something written in RPython. So it's got me hooked.
One more question.
Okay, so first, quick comment just by way of defending the Django benchmark. The reason that is the benchmark, as far as I'm aware, is that Django's most frequent thing getting tagged as Django slow because the template language is slow. I don't believe it is true that it is slow or that it is slow enough that it matters, but that is the reason why the template, the benchmark is that. It's also not intended to be a comprehensive benchmark. It's just a benchmark called Django because it happens to do something that is Django related. What I want to follow on from that is that I've got essentially the same sort of question back at you about your benchmarks. We didn't see the code that you were running exactly. So can you summarise it all out of the benchmarking that you have done, what your perception of what PyPy does fast and what it does slow? And is it I/O operations that are going to be exactly the same, but if you do fast looping or lots of small loops, it's going to be faster? Or where did your benchmarking take you in terms of what's faster and what isn't?
Well, I mean, I/O seems to be very fast, and certainly with the XML writing out, because I was writing to a file, there does seem to be a little bit of improvement there. I mean, I was using just the standard SAX that comes with XML lib, and normally that's sometimes I've had a few performance problems with that, even in the writing thing. It really picked up on that, and when you analyse it, it's because it is looping really heavily. So when you say end tag, a whole lot of loops and stuff go off. And I've got to be a little bit careful. The JIT doesn't just do loops. I mean, loops is where it's going to get its big win. And the second link on the resource I gave, Benjamin, who did the JIT for PyPy, explains it really well. I mean, I was surprised that so much improvement was in the XML stuff. I really thought that the parsing in the CSV thing was going to really be improved by the JIT. In the end, what I found, thanks to somebody else who'd done a bit of tracking, is the parsing of floating point wasn't quite right, and the way they were parsing one other part was it was sort of doing it a little bit repeatable. So by changing those things, it made it easier for the JIT to kick in. And in some respects, that's what even the PyPy guys will say when you watch them talking about where they have problems, is you look at why, what was the reason why it wasn't optimized, because the JIT has this thing where what it calls guards. So when it's done its tracing and it decides to break it down, it sets this guard, and it's basically got these little checks saying, have these variables changed? If these variables changed, it has to jump out and go back and start back in Python again. And so I'm sort of guessing where I'm having problems in some of the other ones where I think the looping should be a win for me. We're getting in a situation where basically those guards are getting triggered, and it may be as simple as changing a variable and things like that. I'm not an expert. This is 6 weeks of fiddling, and not full 6 weeks. It's when the day job was free. Or normally when I'm on a plane is when I'm doing this type of stuff. So, but it is a thing. And you're right about the Django thing. I mean, there's one site that supposedly ran Django for a long time, running under PyPy. Sadly, now that site is converted to Scala. And part of the reason was it was for page rendering and being fast. And as you said, it's a pure perception thing. We all know with Django there are ways you can make the rendering problem not be the impact that everybody imagines it is.
Thank you, Mark.
Thank you.